In part 1 of Unit 14, we're going to talk about spontaneity and the first law of thermodynamics. We've talked about the first law of thermodynamics before, but it says that the total energy of the universe is constant. It's another way of saying energy can't be created or destroyed. It can, however, be converted from one form to another, or transferred from a system to the surroundings, or the surroundings to the system. Often you'll see this written with an equation, U being the energy of the universe is equal to the energy of the system plus the energy of the surroundings. So that was just a reminder of what the first law of thermodynamics is. It's pretty easy. Now let's talk about spontaneous processes. Spontaneous processes are those that can proceed without any outside intervention. They're processes that just happen. So if we look at this picture at the top right here, we've got gas at one atmosphere pressure on one side and a vacuum on the other. And when we open the stopcock that's connecting the two sides of the gas chamber, half of the gas will spontaneously move from side A to side B. That's a spontaneous process. All we had to do was connect the two sides together, and the gas spontaneously moved to side B. The reverse of that, everything moving back in to side A, is not spontaneous. That's not going to happen without any sort of outside intervention. Processes that are spontaneous in one direction are non-spontaneous in the reverse direction under the same conditions. So in this picture here, when the person lets go of the eggs, they're going to spontaneously fall down and break. Under those same exact conditions, the reverse of that can't happen. The eggs are not going to magically go back together and jump back up into that person's hand. Processes that are spontaneous at one temperature may be non-spontaneous at other temperatures. For example, if the temperature is above 0 degrees Celsius, solid water or ice will spontaneously melt. That won't happen below 0 degrees Celsius. In fact, the reverse process is spontaneous. Liquid water will turn into solid water below 0 degrees Celsius. So temperature is one of those conditions that can have an effect on whether a process is spontaneous or not. In fact, it can even control which direction a process is spontaneous in. Some processes are reversible, and that means that the system and surroundings can be put back in their original states by reversing the process. Usually to do that, energy has to be added, but it can cause a process to go in reverse. Think about like a cell phone battery. It spontaneously provides electricity to your cell phone while it runs itself down, but when you plug it into the wall and add energy, it reverses that process and charges up the battery instead of discharging it to use your cell phone. Some processes are irreversible. They can't be undone by exactly reversing the change to the system, no matter how much energy you add. We can't unpop popcorn once it's been in the microwave. Spontaneous processes are often irreversible. Let's talk about equilibrium and reversibility of processes. When a system is in equilibrium, we can go reversibly between the reactants and the products. So in any spontaneous process, the path between the reactants and products is irreversible. So if we look at this diagram here, if we have a temperature above 0 degrees Celsius, ice melting is a spontaneous process and it's irreversible. Or below 0 degrees Celsius, water freezing is a spontaneous process and it's irreversible. But if we're at 0 degrees Celsius, however, water and ice are in equilibrium and we can reversibly convert back and forth between the two. Okay, just because a reaction or process is said to be spontaneous does not necessarily mean that it's fast or has a high rate of reaction. A reaction can be spontaneous and still have such a slow rate that no change is easily observed. So under the right conditions, you can have a spontaneous reaction like this big explosion here, but an old car rusting over several years is also a spontaneous reaction. It's just very slow. Okay, your question for this section. At 1 atmosphere pressure, dry ice, which is solid carbon dioxide, sublimes at negative 78 degrees Celsius. Is the transformation of solid carbon dioxide to gas spontaneous at negative 100 degrees Celsius? You might need to find a phase diagram for carbon dioxide to answer this.